This lesson is Unit 2, Section 2, and we are on Day 3 of Chapter 4. So there's something called an even function and an odd function. So even functions are functions that are symmetric about the y-axis. So exactly as it appears on the left side, it'll appear the same way on the right side. Or you could look at it as a reflection over the y-axis. An odd function has every point that was negative x, negative y, you have the same point positive x, positive y. So it's almost like a rotation 180 degrees, or a reflection in the x followed by a reflection in the y. Odd functions have to pass through the point 0, 0. If they do not pass through the point 0, 0, they're not odd. So if it doesn't look symmetrical on both sides, and it's not the opposite on the two sides, it could be neither, right? Functions don't have to be even or odd. It could be neither. So algebraically, what we would do to determine if a function was even or odd or neither, you would plug negative x in place of every regular x in the equation. If you end up with everything being the opposite sign, you end up with negative f of x, the function is odd. If you get the same thing you started with back, it's even, and if it's neither of those, it's neither. But there's actually a shortcut we can use. If all of the exponents are even, the function is even. If all of the exponents are odd and there is no constant term, the function is odd. And if it doesn't fit both of those, it's neither. So let's look at some examples here. If I look at A, I have a power of 3 and I have a power of 1, right? Even though they don't say it, it's a power of 1 there. So those are both odd powers and there is no constant term. So this function is odd. When I look at B, I have a power of 4 and a power of 2. Those are both even. This is irrelevant, right? That's really a power of 0, which I can call kind of even. But 4 and 2 are both even, so this function is even. In C, I have a power of 3 and a constant. But because I have the constant, now it's neither. Okay, if I look at D, my function did not pass through 0, 0, and it doesn't match on both sides, so this is neither. For E, it's a reflection. Whatever happened here, happened here. So this is even. And for F, it goes through 0, 0, and whatever happened here, the opposite happened here, so this is odd. So go ahead and try the next 4, pause it, and I'll show the answer. Okay, so number 1 was odd. It went through 0, 0, and then the same thing, or I should say the opposite thing happened on both sides. 2 did not pass through 0, 0, so it was neither. 3 had 4 and 6 are both even numbers, so that's even. Number 4 had 7, 3, and 1. 7, 3, and 1 are all odd, so that's odd. The other thing we're going to talk about this lesson is we're going to go back to transformations. So we've talked about transformations before, horizontal and vertical translations, we talked about reflections, and we talked about vertical stretches and shrinks. So we're just going to add another one here, horizontal stretches and shrinks. We're not really going to go much into the horizontal right now. But remember that it's always the opposite sign inside. So negative 5 really meant 5 units to the right, plus 2 really meant 2 units left. If it's on the outside, it's whatever happened outside. So plus 1 was 1 up, minus 4 was 4 down. We really focused on this kind of reflection, right? When we multiplied the term by the negative, we didn't put the negative with whatever power there was. So if it's on the outside, it stays on the outside. If they put it on the inside, it goes on the inside of the parentheses with it. Horizontal stretch or shrink is when the number is actually attached to the x. So it's happening with whatever's being squared or whatever power is happening. But we take the reciprocal of it to describe it. So a 2 on the inside, if I take the reciprocal, is really a 1/2. So it's a shrink of 1/2. A 1/2 on the inside, the reciprocal is 2. So it's a stretch of 2. The vertical stretches and shrinks remain the same. They happened on the outside, they stay on the outside, and if it's bigger than 1, it's a stretch. If it's between 0 and 1, it's a shrink. So we did all of this when we talked about absolute value and when we talked about quadratics, but they can happen for any polynomial. So any of the higher degree functions we're looking at, and we're going to focus specifically today on x cubed and x to the fourth, we can do these same transformations. So here, we're given that f of x is x cubed. We want to write g of x if, so for a, g of x is equal to f of, in parentheses, x plus 2. So that means where the x is, I'm going to replace it with x plus 2. So since the x was being raised to the third power, now the entire x plus 2 is being raised to the third power. And that's all we have to do for that problem. So this one, they're showing us a minus 6 afterwards. So that means after I do my x cubed, I'm going to put a minus 6 afterwards. And for this one, the 4x is inside the parentheses. So that means inside the parentheses, I'm going to put 4x. All right, and that's all we had to do for these. So you go ahead and try these three. Right? Notice we're doing x to the fourth this time, so just make sure in your answers you include x to the fourth. Pause it and I'll show the answers. All right, go ahead and check your answers. All right, moving on. So this is a little different. This is already giving us an entire polynomial, and they want us to change it into g of x by doing whatever transformation they're describing here. So for this one, they want us to plug in negative x anywhere there was an x. So I'm going to start by showing that step. I'm plugging in negative x to the x third. I'm plugging in negative x to the 2 times x squared. I'm plugging in negative x for the x, and then I just write 4. So if I did negative x to the third power, that's a negative times a negative times a negative. A negative 3 times is a negative number. So that's negative x to the third. This is 2 times negative x squared. Negative x squared is negative x times negative x, or positive, so that's going to stay plus 2x squared. Plus a negative is minus, ooh, that's a bad one, minus x, and then minus 4. So that's our answer for the transformed function g of x if f was of negative x. For b, they have a 2 on the outside, 2 times f of x. So that means we're going to do 2 times the entire polynomial. Right? If the 2 was in here, that means I'd be plugging in 2, but this means 2 on the outside, 2 times everything. So my g of x in this case is going to be 2x cubed plus 4x squared plus 2x minus 8. So we're really distributing the 2 to everything. All right, you go ahead, try this one, pause it, and I'll show the answer. All right, so there's our answer for that one. So we're going to go back and we're going to now describe the transformations. So remember, we're looking at negative in front means a reflection, A number inside, we take the opposite, and that's left or right. The number outside, we take exactly the same, and if there's a number in front, that's a vertical stretch or shrink, depending on if the number is bigger than 1 or between 0 and 1. So for this one, we have a negative sign, so we do have a reflection. The -3 inside is really 3 units to the right. Okay, opposite of negative is positive. And then the -4 is 4 units down. So that's our description of the transformation. So now we're going to make our tables of values. We'll still pick -2, -1, 0, 1, 2. But now for my y's, I'm just not going to put 2, 1, 0, 1, 2 because that's not what my function is. My function is x cubed. So if I take -2 and put it in, -2 times -2 times -2, I get -8. And -1 to the third power is -1. 0 to the third power is 0. 1 to the third power is 1. And 2 to the third power is 8. All right, so that's my x cubed table of values. For my transform function, though, remember the inside, x minus 3, we're going to do the opposite to x plus 3. And then we're going to take the negative times y and then minus the 4. So each of these x's here, I'm going to add 3 to them. And each of these y's, I'm going to start by taking the negative. So the opposite of -8 is +8. Minus 4 is 4. The opposite of -1 is +1. 1 minus 4 is -3. 0 minus 4 is -4. -1 minus 4 is -5. And -8 minus 4 is actually -12. And I know that goes off the graph slightly, but we're still going to graph it. We can get there. So we have the point 1, 4, 2, -3, 3, -4, 4, -5, and 5, -12. So graphs like this are going to, let me try and start that over. Did not like that. 1, 4. So we're going to go down. We're going to curve it here, and then we're going to go down again. Right, and that's what an x cubed graph kind of looks like, right? This is obviously the transformed one. Our original one would have gone like this, if you wanted to see the original. But this red one is our transformed one. Let's do another one. So now I have f of x equals x to the 4th. And I'm going to do 1/2 times x plus 1 to the 4th minus 5, and then I'm going to graph the transform function. So the 1/2 out front is what tells me I have a vertical shrink of 1/2. The plus 1 is 1 left, and the minus 5 is 5 down. And I'm going to stick with my -2, -1, 0, 1, 2, only because if I gave them even numbers just to counteract this, I'm going to get numbers that are way too big that don't fit. So I'm okay with these. I'll end up with some fractions, but that's dealable. So now we're doing x to the 4th. So -2 to the 4th is -2 times -2 times -2 times -2. So that ends up being positive 16. -1 to the 4th is positive 1. 0 to the 4th is 0. 1 to the 4th is 1, and 2 to the 4th is 16. So if we wanted to see what this looked like, we're going to have our points way up here that we can't see them. So what really looks like this, it gets really close to the axis here. It looks like a really flat kind of view when we're dealing with x to the 4th. So now let's look at a transformed version. So we know we're going to do the opposite of x plus 1, which is x minus 1. And we're going to take the 1/2 y and minus 5. So take away 1 from each of these, and I get the x's. Now I'm going to take half of 16 is 8, minus 5 is 3. Half of 1 is 1/2, minus 5 is negative 4 1/2. Half of 0 is 0, minus 5 is negative 5. And this one should be symmetrical again, so I should get negative 4.5 and 3. So we're going to have the point negative 3, negative 3, positive 3. Negative 2, negative 4 1/2, negative 5, negative 1, 0, negative 4 1/2, and then 1, 3. So really flat U, and then back up. All right, so we can make any table of values depending on whatever the parent function is. We can always use our transformations. We know how to make our table of values based on the transformations regardless of what our parent function started as. So you're going to go ahead and try the last one. You can pause it and I'll show the answer. All right, so there you go. That is your answer, and that is the end of this lesson.